Okay, so let's talk about some strategies for number 14. The strategies could be to graph all of these, and that's going to take a long time, but it's okay. You can do that. What I would do is I would take each one of these over here, and I would go ahead and I would multiply them out. So step one is going to be, listen, step one is going to be to take this part here and FOIL it, okay? I'm going to number these 1, 2, 3, 4, so you know which one I'm talking about. So on the first one, number 1, we are going to FOIL x minus 3. So you would get x squared minus 6x plus 9, and then we add the 4, okay? So that would give me x squared minus 6x plus 13. Which one does that match up with? Which one? This one right here. Okay, so there's that one. Okay, now if you was graphing this, then you would, once you eliminate 1, you could delete that out of your y1s, and that would be one less thing to look at. If you need to see the extra steps foiling, come in and see me. Okay, number 2. If I FOIL x minus 3, we already know what that is. We just did it. X squared minus 6x plus 9 minus 4 this time. So I would get x squared minus 6x plus 5. So it matches which one? The very last one. Okay. Next one, this time we have a plus sign in between there. So it would be x squared plus 6x plus 9 plus 4. What's 9 plus 4? No, we didn't. Which one does this one match? The very, very first one. So, unless we did this wrong, probably process of elimination, it should probably go right here. But let's make sure we didn't make a mistake. Okay, so on number 4, I have x squared plus 6x plus 9 minus 4. What's 9 minus 4? 5. So did that match our last one? Yes, good. Okay, so good. So far, so good. Now, I don't have time to go into a big, long spiel about natural log, which is what these are, okay? Unless we start out with natural log, it will not be an answer. And we did not. We went from an exponential, and they want us to put it in, oh, it says all that apply. It says all that apply. Okay, so I can't cross these out. It says to select all that apply. Natural log is like a log, but you cannot change the base. So Dylan, the base of a log when we don't have the number down there is always what base? 10. Thank you. Yeah. That would also be for natural log. Okay, so they gave us 4 to the x equals 12, and we need to, Dylan, write it as a log. So log base what?
10.
Log base 4 equals x, which is also 12. Okay, remember when I told you if you cannot get these down to the same base, that we could do what we called a change of base formula. Okay? And we said that one of the logs goes on the bottom and one of the logs goes on the top. Which one's? Yes, because it's already lower than the 12, so it goes on the bottom. My 12 is bigger and it's at the top, so it stays on the top.
I totally did something different.
Okay? So.
I took 4 and took it to the other side.
All right, so is A the same thing? No. Is B the same thing? Yes. Okay. Is C the same thing? No. What about D as in dog?
No.
Yes. I just said natural log is like log base 10. So it would give you the same answer. All right. Now it looks like they're saying they're wanting to see if we rewrote this thing the right way. So which one of these matches the way we rewrote it? E. Okay. So there was 3 right answers on that one. Okay, let's go to number 16. Number 16, which are factors? How could I find factors? What would be a really quick, easy way? Okay, exactly. So watch, if I graph this thing, what am I looking for when I graph it? What's going on? Why is my thing blank? There we go. Why is it blank on? Okay, this is really weird. Like you can see it on the iPad, but you can't see it up there.
Whoa. Ghost.
No, I'm serious. Is it the brightness? Oh, shoot.
Because it's probably still focused on the paper.
There you go.
Hang on, it's getting there.
Okay. What am I looking for on factors?
Whatever, touch the X.
Yes, so where does it touch the X at?
-4, -2, and 1.
-4, -2, and positive 1?
Yes.
Okay, positive 1. How do I write those, though, as a factor?
X plus 4.
So this would be x plus 4. This one would be
X plus 2.
x plus 2. And this one would be?
X minus 1.
Okay. Can you tap her desk and get her head up, please? Okay, so we got to circle all that applied. Is x minus 4 one of them? Trinacia, head up. Oh, okay, okay. All right, what about this one? Sorry, I thought you were sleeping.
No.
This one's no. Okay, what about this one?
Yes.
Yes. What about this one? No. What about this one?
Yes.
And this one?
Yes.
Yes.
Done?
Okay, so there was 3 right answers on that. All right, here we go. Whoops, sorry. All right, let's look at number 12, or number 17. Number 17 has 2 parts. The first part says, which of the following is the inverse, okay? What I said we could graph these, look for the butterfly effect, right? But what is the first rule for finding the inverse? We switch what? Yeah, so this would be x equals 1/2 y minus 6. So the first thing we're doing is we're swapping x and y. And f of x is just a fancy y. Now we have to solve for what?
X minus y.
Solve for y. So the first thing I need to do is move what?
6.
So add 6. Okay, x plus 6 equals 1/2 y. How do I get rid of that 1/2?
Divide. Or multiply by 2.
Yeah, multiply by 2 would be the easiest. Okay, what is 2 times x?
2x.
2 times 6, 12. So that equals y, which is also the inverse. So which one does that match? Yes. Okay, now, we don't even have to do any math if we remember the rule on part B. This is how we used to check and make sure we had the inverse. If something is an inverse and I plug it into the other, what does it leave me with? What'd you say?
1.
Close. It would be 1 if I didn't have variables, so it's going to be 1 x. So it's just x. If we did this right and I plug one into the other, I should get nothing more than x. And we can try that really quick. So I'm going to start with the original. So the original, 1/2, there's my x that I'm going to swap out. And I'm going to swap it out for the inverse. Okay, what's half of 2? 1. What's half of 12? What's x plus 6 minus 6? Isn't that what we just said? So you didn't even have to do this work, okay? All you had to know is the rule. If that is the inverse, all it leaves you with is x.